The other well-known figure is Manu, who's 6G's research senior director at Northeastern University, but he's also got lots of other hats that will, are very difficult to describe. But, one of the important things is that he's former board alumni of OpenAirInterface. So he used to be a board member, and that he handed over to Tommaso last year. And Manu is also serving as advisor to the Office of was that defense people, right, in the US? OUST.
Yeah, there are
so Mamo will speak about that.
Do not look from the crowd, so don't worry about that.
So he's going to speak about the power platforms.
Okay, sounds good. Thank you. And I think the agenda that was set was done really well, because leading in from what Arpit had talked about, I think I'll pull the focus back more to the academic realm and sort of walk you through, as Irfan said, I was on the OAI board since last year, and I had the honor and privilege to do so under the auspices of this program since 2017. So you've heard about this project, I believe, from some of the demos, some of the hallway conversations, and maybe a couple of the talks over the past day and a half. But I wanted to just give you a sense of where the US government, the US academic community has been going as it pertains to open source, Open RAN, and as we look ahead into the future, how what we've built under this program could inform the development of what we've talked about here, an open end-to-end, both horizontal and vertical, leveraging open interfaces, leveraging open commodity, hardware and software, a fully robust, performant, compliant, standards-based platform. That's quite a mouthful, but sort of how did we get there, how we thought about it, what our approach was. So it's a little bit of a historical context, but also helping inform what we are going to see and what we are already seeing in industry and academia going forward. Okay, so just, the usual spiel of what this program is. It's a bunch of acronym soup, so please just, raise your hand and let me know if I go too deep. So this is a Platforms for Advanced Wireless Research program, started back in 2017. So, think back 7 years, where you were you working on 5G at that time? Were you working on commercial technology, Wi-Fi? But at that time, the US government sort of came together alongside us as an academic partner and the middle entity, which is a 501c3, which is basically a nonprofit entity called US Ignite, to kickstart this program. And what the intent with this program was to build an open research infrastructure at scale, indoor and outdoor, to allow the academic community to really undertake testing with mobile communication systems in a standards compliant way. Up until that point, obviously, we know the best of breed open source communities. We're here in one of them, and that was something that, as you'll see, was a key backbone piece and a key kind of critical component for us, and that's why we sort of partnered with OAI and the Software Alliance back in 2017. And what we wanted to do, supplemented with about 30 different companies. I did not change the logo. If a keen eye is going to notice Facebook, that's no longer Facebook. But again, this is sort of the original consortium of 30 companies. So in terms of scale, not to impress you with numbers or throw some big numbers around, but it was about $100 million all said and done, 50-50 between industry and academia. And the goal was to build these large-scale platforms. And it was quite ambitious at that point, because again, in 2017, we had certain pieces, but they weren't quite there in terms of doing things at scale. They weren't quite robust. They weren't quite performant. We were sort of getting there. The curve was getting, shorter and shorter. But we really needed to kind of put them through the ringer, so to speak. And I feel kind of proud that this program was the catalyst that allowed the U.S. community, both academia and industry, to come to the fore to build these infrastructure. There's no glory in here for myself or any of my colleagues as part of the project office. The glory is with the platform team, some of which are present in this room today as well. So I'll quickly give you a sense of what our programs are, what our portfolio looks like right now. And if you are an academic student, I think this would be a good opportunity for you to understand that these are neutral test infrastructure environments that are remotely accessible, that are available to you, because I understand, that is always a pain point for anybody in academia or somebody who's not as well resourced or well funded as an industry lab to leverage the kind of commodity hardware and software in a fully supported operationalized kind of manner. And the idea here is to test at scale in emulation. You could do that in the cloud today, but we allow you to do this both in the cloud, in a digital environment, but also outdoors in a real environment, and validate your findings in there. So what are we actually looking at? Again, we're a little bit beyond just 5G. So as you can see, certain elements of the architectural picture that Arpit put up of what we're seeing in 3GPP and ORAN, all of that sort of organically fit in. And again, I'm just doing a chronological time check, right? So 2017 is when we kicked things off. The ORAN Alliance, et cetera, was formed, but really it came into its own in the latter part of 21, 22 timeframe when we actually started seeing artifacts, work products, reference architectures come out to play. And we had sort of put this program and the platforms that we developed as kind of being extensible, adaptable, modular, and flexible to accommodate these evolving kind of network architectures. And that actually really fit really perfectly well together as we evolved, as the community involved, and as kind of industry became a little bit friendlier to open interfaces and open source software. So don't want to read the thing, but these were our research disciplines that we wanted to foster when these infrastructures that were being developed. So we are all over the place, as you can see. We're looking at intensive RU, radio unit technologies like massive MIMO. We were looking early on at AI/ML, whatever incarnation it was, back in 1819. We were looking at virtualization and orchestration of network architectures, cybersecurity. We looked at FR2 and millimeter wave. Spectrum sharing, that is quite a big topic in the US context. I'm not sure about it globally. And then obviously this term that sort of is near and dear to my heart and also to this community, which is around open source hardware and software development. And oh, by the way, we wanted to motivate all the infrastructure development with over-the-top applications as well. So we really leaned in on UAS mobility as well as some of the rural applications that you may have heard Professor Zhang talk about in the context of the ARA platform. So yeah, spectrum management, this is kind of important. I don't want to get too deep into this, but what this sort of allows, one of our platforms, PAWR, which is based in Salt Lake City in Utah in the US, allowed for testing spectrum sharing in a zero-touch, automated, AI-enabled manner, where you essentially have the notion of a central spectrum exchange that spoke with incumbent legacy operations, whether it be 5G or commercial operation or a military tactical radio, and how it would interface and speak with 5G. At this point, this was all built on top of OAI because we did not have any kind of commercial vendor ecosystem that was willing and able to provide the level of information, the level of details we needed from the CU and DU. And again, I acknowledge what Arpit said around commercial aspect, but this is kind of a blessing for the academic community that is really trying to very quickly build prototypes and show proof of concepts and pilots initially, and really helped us kind of deliver this kind of a solution to a large customer, the US Department of Defense. And that kind of a system now has matured to a very high TRL and is right now being considered, which in the US government acquisition cycle is called a program of record, which is when the US military buys services from a vendor. So kind of proud that that got its start within the auspices of the program. The second one, this acronym, the RDZ, is a concept of a radio dynamic zone. So again, as I talked about, spectrum's a finite resource. In the US, you have multiple legacy different systems, and you need them to be able to coexist. We are also looking ahead into the 6G era as FR3 comes to bear, and we'll have to start thinking about incumbent systems between the 7 and 15 gigahertz space, and how are we going to work on that. And basically, these platforms, given their flexibility, given the spectrum agility, the the software-defined radios, and the programmable RF front ends that we have is a key resource that allows us to sort of work on this topic. ARA, again, to shout out here to Professor Zhang and team, they are, in the context of our platform and in the US context, one of the only end-to-end implementations that is working outdoors at a scale environment. Obviously, we've seen some of the work that we've done, and congrats again to Hongwei and team on a successful ARA Fest, where they basically were able to demonstrate large-scale rural applications all running on top of OAI. The platform PAWR, again, out in Salt Lake City, is a testing ground for OAI, mobility-based handover experimentation. And I guess the key takeaway of this slide is that we are a voracious consumer of what the OAI community produces. And we're able to sort of test a lot of that software, make it more robust, make it more performant, and really interact closely with the developer community, but also the testing and use case community to really kind of push the boundaries of where we can take this resource. So sort of, I feel that, these test platforms, the operators of the platforms, the users, the experimenters are kind of a key catalyst in pushing where we can take OAI and really close the curve with close the gap with the commercial curve, as we are seeing, in the 3GPP realm with the completion of Release 18 and a lot of the open features that we need in academia that are kind of getting up and close to some of the Release 16, 17 features. We are maybe, one release behind. And again, I think Raymond has historically in his talks talked about how far back in the 4G days the OAI stack was where commercial stacks were, and how close we've gotten in 5G. And at some point we will be in lockstep and maybe not that far behind in some of the future releases. Okay, have to give a shout out to ORAN. So all of the test platforms that we've developed, and again, this program was the inception of it was 2017. The platforms began to get developed in 2019, and as of now, we have all of these platforms certified by the ORAN Alliance as OTIC. So again, open test and integration centers have a very strong, keen interest from some of the vendor ecosystem partners that are in the room here, but also a larger cohort that have partnered with these test infrastructures to conduct, component testing, performance testing, interoperability, conformance, and now slowly we want to move towards the topic of supporting industry verticals and applications in these platforms. And again, participated in multiple different plug fests, so have significant experience with that. If you are somebody who's sort of getting interested in this topic area, there are multiple profiles or software customized profiles that are available for you to kickstart from wherever in the world you are on this remotely controlled test infrastructure that's available and accessible to you. Again, this is, just wanted to put this up. Don't have much to say more than what Hongwei shared, but this is kind of one of the application research areas that we are supporting as part of the PAWR platform. Okay, so key elements, remote accessibility, real physical infrastructure, real SDRs, weatherized, ruggedized, put outdoors, they are maintained. You have a whole team of people in geographically distributed areas, New York, Raleigh, Ames, Iowa, as well as in Salt Lake City, alongside different software profiles. Obviously, OAI is one flavor of it, but we're also looking at different technologies like unlicensed, IoT, UAV-based command and control systems, and then the spectrum issue, which is kind of a big deal in the US. And this all comes supported with expertise and services that are up until now have been supported by the National Science Foundation. Okay, this is kind of a nice sort of a chart, but again, just shows you a little bit of the complexity at play here, right? So you have this notion of outdoor test beds that are controlled with multiple base stations, UEs, multiple different software profiles. So think of it as mix and matching. Think of them as modular elements, given the disaggregation we've seen with ORAN. So you can pick a flavor of multiple different open source communities and then kind of make them work together for whatever application use case you want. If you're looking looking for some obscure 3GPP feature because you want unlicensed spectrum access, you want side link communications, things that aren't available in the commercial system. You know it as well as I do. We sort of build that stuff mostly on the open source community software packages, in this case, OAI. And this is, again, organized in the different elements that I talked about earlier: outdoor, indoor, the software, the spectrum, and the services. And again, all of this is maintained as a single package for an experimenter and user. And I think it'll make, it'll get your respect knowing if you have tried to put together software in an SDR, wheel out a little cart outside your lab and try to connect things and see how they work. So trying to do this at scale over a larger geographic footprint and doing this in a repeatable, reproducible manner is quite an achievement. And that's what some of the platform teams that we've selected to do have been able to do. So this just gives you a look of what the Utah campus looks like. Bottom left is one of the massive MIMO base station arrays. So this is a fully programmable massive MIMO base station array operating at CBRS, 3.5 gigahertz spectrum. And these are kind of the geographic distances. And on the right side are campus shuttles that are outfitted with mobile nodes that allow you to also conduct mobility-based experiments, handovers, etc., on the Salt Lake City, Utah campus. Cosmos, again, I'm not going to go through each of these. I think the key piece here is alongside OAI, you're able to leverage this testbed for optical networking. So they have a fully programmable optical backbone built on top of the reconfigurable optical add-drop multiplexer. So ROADM modules that are connected across multiple different software radios, as well as millimeter wave-based radios that are deployed at Columbia University in downtown New York, and also our partners at NYU. So you have the ability to sort of have a large number of IQ samples that are zipping around on the optical backplane, so you are able to do multiplexing and switching in the physical domain. And this is, again, we could hire an IT pro and do cabling here, but that's not the intent of this slide. The intent is just to show a large-scale kind of optical switch. So that's an S320 switch up top, which allows you to sort of multiplex. So it's a star topology. All the radios that are out there sort of come back and converge down here in the physical domain, but in the optical domain, you're able to develop any kind of a virtual topology on top of this physical infrastructure. And that's sort of what the fiber connectivity that we're running on top of is shown there. AirPower is the UAV testbed, so this is more focused on mobile. I would call this the extreme use case for us, and I will be kind of honest and candid. This is more, or has been a very hard journey in terms of getting performant, reliable mobile communications implemented, given all the constraints of mobility and also swap, size, weight, and power. We are trying to mount software-defined radios on top of UAVs and UGVs. We have command and control issues, we have mobility-based issues, and this is, in terms of geographical area coverage is not necessarily as big, but this really does, want to acknowledge this team for sort of being able to provide a large-scale mobility-based test bed, leveraging OAI over, commercial spectrum. So this one has a mix of both a commercial Ericsson 5G system and a open source OAI-based system, and kind of showcasing the interworking between the two, given the sensitivities of URLLC-based applications that we have at AirPower. And this sort of is the field where you have multiple different base stations. You have these large kind of UAV octocopters that have big kind of RSNI SDRs mounted onto them with multiple different radios pointed downwards, and quite sophisticated management systems, and across about a mile or 2,000 meters, 2 kilometers of range. ARA, I'm just going to skip in the interest of time, because I'm presuming we've heard enough from Professor Zhang and his conversation and some of the demos and posters that he's going to present. But all I wanted to sort of acknowledge here is there is, again, a large diversity of what these platforms are maintaining. So on this singular platform, you have heterogeneity in terms of SDRs that are supporting the DC to 8 spectrum. You have massive MIMO base stations in the TV white space. You have the free free space optical communication that's happening at, at the terahertz point-to-point link, and all of these being kind of fully programmable, and also a fully commercial Ericsson 5G system architecture. So with that, I'll kind of wrap up. Just really wanted to, key takeaway here is this journey over the past 7 years, and we're going to continue it as we kind of meet the standards bodies and fundamental research topic areas as they evolve into 6G. But we feel that what we've built on top of open source with open interfaces and programmable infrastructure, this scale will kind of allow this community to really foster and close the gap in terms of providing the compliant features that we need in the future. So thank you for your time and attention, and please contact me if you have any questions. Thank you for your time.
Thank you, Manu. Questions?
Hi, thanks for the presentation. Please, could you comment on the accessibility of these platforms from outside the US?
Yep, so that's always the question we get with an international audience. So I think the most correct way, and I've kind of finesse this answer over the years, is I would say it's best effort. So we don't say no. So if you reach out to us, if you reach out to an individual platform, they would gladly give you access to the test facility. But given that those resources are highly in demand, and depending on what you want to do, we do, I just want to set expectations up front, right? So this is something that's going to be available to you best effort, because the priority right now, given the funding is coming from the US funding agencies, is for a US-based researcher. But I would say yes, and best effort in terms of what you can expect to get an access to. But in terms of onboarding yourself as a user, it's a very lightweight process. Simple mailing list, reaching out. They just want to verify who you are. If you're a faculty, that's the only kind of main check metric we use, is we need a cognizant and a responsible faculty member to request the account, and then the downstream, the students can access the resources obviously within the acceptable use policies, etc., that you'll need to adhere to. So hopefully that's a satisfactory answer. And if you want to reach out, please do reach out to me or to the individual platforms.
Any other questions? So I wanted to say further to what you just said, Manu, for the platform of Professor Hongwei, we were given access to at some point in time when we were collaborating for the issues on the UE, handover topic. So the access is obviously technically possible and interest-based. So, any other thing? Thank you, Manu.
Absolutely. Thanks a lot.